grab some more paper here. Here we go. Okay. Today is 3.4 day 2. We are going to solve logarithmic equations using exponents. So it's the opposite of what we did yesterday. Yesterday it was exponential equations using logarithms. Today it's logarithmic equations using exponents. So here we go. Okay. So there's some kind of basic strategies that you can use to solve logarithmic equations. So some things that we want to be aware of ahead of time. First thing, important. If there's more than one logarithm, put all the logs on one side and all the other stuff on the other side. And this is if you have like a mix of logarithms and other things. If you don't have a mix of logarithms and other things, if you just have logarithms like one on one side and one on the other, then you can kind of deal with it differently. But if you have a mix, put all the logarithms together on one side and all the other stuff on the other side is kind of a good rule of thumb. And then if you have multiple logarithms of the same base, try to combine them first. Okay. And so today, kind of like yesterday, I'm going to show some of the basic examples and the things that you'll see in your IXL section today. And then I'll also show a couple of more complicated examples, maybe one or two more complicated examples that you won't see nearly as often, but are still good to have seen before. So, first example. We've got 2 log base 5 of 4x minus 1 equals 11. Okay. So even if you don't have multiple logarithms, if you have logarithms and other things, you want to make sure that you put the logs on one side and the other stuff on the other side. So that's what we're going to do first here. I'm going to add 1 to both sides so that we get 2 log base 5 of 4x equals 12. Then I'm going to divide by 2. Divide by 2 on both sides. Okay. So that we get log base 5 of 4x equals 6. Once we get down to something like this, then what we can do is kind of the opposite of what we did yesterday. So remember yesterday we would have exponentials and we would log both sides. Well, now we're going to exponential both sides. So this is kind of the same idea as we had when we were changing logarithms into exponents in general. Remember, we would have something like we would have like log base 2 of 8 equals 3. And then to change this into exponential form, we would put a 2 underneath each side to cancel out the log base 2. So we get 8 equals 2 to the third. We're going to do the same kind of thing here. So since we have a log base 5, I'm going to put a 5 underneath both sides. So we get 4x equals 5 to the 6th power. Then 5 to the 6th power is something you can type into a calculator, because I don't expect you to know 5 to the 6th power off the top of your head. I sure don't. And we get 15,625 equals 4x. And then we just divide by 4 on both sides. So x equals 3,906.25. And that one's an exact value. If you don't get something that's very exact, if you just get a bunch of, like a long string of decimals, go ahead and round to 3 decimal places. This one doesn't require that, just because it comes out evenly to 3,906.25. Okay, so that's one kind of question that we might see. And that's even slightly more complicated than your IXL section will start out today. Your IXL section is going to start off with something like this. It's going to start off with like log base 4 of b is 17. And you want to figure out what b is. So in this most basic form, we're basically taking this, we're starting down here at this step. So we didn't have to do any of this cleaning it up here to get it to a place that we could solve it. All we have to do for this one is stick a 4 under both sides. So b is 4 to the 17th power, which is quite a large number. I probably should have picked something smaller than 17. Oops. Will it do 4 to the 17th? It will. All right. So you get a very large number, 1.718 times 10 to the 10th. So that would be, let's see, if I move this decimal over 10 places, 1717986. Perfect. So that would be our answer. 17,179,869,184. So that's going to be the most basic type of problem that you'll see, where you just have to put the number underneath and then find out what the exponent would be with a calculator. Okay, so that's how it is with just one logarithm in the equation. The next thing we want to do is, well, what if there's more than one logarithm that we're dealing with? So for our third example, we are going to do log base 5 of 8x equals log base 5 of 2x plus 1. Now this case is even easier when you have something like this, where you have the same base on both sides. Because all you need to do, you can either think of it as, well, what's inside here must be the same as what's inside here in order for them to be equal. Or you can think of it as, well, I'm going to put a 5 underneath both sides. Since if I do it to one side, I have to do it to the other. And it cancels out my log base 5 on both sides. So we're left with 8x equals 2x plus 1. So then you'd subtract your 2x off of both sides and get 6x equals 1. divide by 6 on both sides and get x equals 1/6. Okay. So those are three kind of more basic examples. I'm gonna have you guys try one before we show the kind of the hardest case here. We're gonna go with 3 log base 2 of we'll go 6x minus 1 equals 18. Okay, go ahead and give that one a try. If you get a decimal answer that's ugly, round it to 3 decimal places. And when you are done, type "I love logarithms" into the chat. All right, we got a lot of fans of logarithms today. So if you started off with dividing by 3 on both sides, you're on the right track. Then you put a 2 in the base of both sides to get rid of the log base 2. So we get 6x minus 1 equals 2 to the 6th, and 2 to the 6th is 64. So then add 1, 6x equals 65. Divide by 6 on both sides, and that would be 10 and 5, 6, I believe. Let's see. Or let's see. 6, 5. Yeah, 10.83 repeating. So you would put 10.833, and there we go. Okay, so those are mostly the kind that you guys are going to be asked to do. The other kind that we will see is something a little bit more complicated, so I'll show you one of those as well. I don't believe you'll see any of these in your IXL sections, but they are good problems to at least have seen before. Put something under this because the other paper is showing through. That's a little better. Okay, so for this one, last example, we've got log base 2 of x minus 6 equals 5 minus log base 2 of 2x. Okay, so this is the kind that we've got multiple logarithms, and we also have other terms in the equation. So what we need to do is get all of our logs onto one side and everything else onto the other side. So what I'm going to do is add log base 2 of 2x to both sides. So we get log base 2 of x minus 6 plus log base 2 of 2x equals 5. Okay. And then using the stuff that we learned in 3.1 to 3.3, we can combine these two things. So since we have addition in the middle, we can combine these into log base 2 of x minus 6 times 2x. Then, once we've done that, now we're ready to kind of be back at that step like we were in examples 1 and 2, kind of where we started here, putting the base underneath, since we've condensed it. So we're going to put a 2 underneath both sides so that we can cancel out the log base 2, and we're left with x minus 6 times 2x over here, and 2 to the 5th right here, which is 32. Then there's a couple different ways you can go about this. Personally, what I would do real quick, noticing that there's a 2 here, is divide both sides by 2, just to make this side as simple as possible before I do anything else. Ender. Bud, come on. Oh, man. He heard someone shut a car door outside, and, you know, that's cause for panic. Anyway, we get over here, we're left with x and x minus 6, and then over here, we're left with 16. Pop, come here. Ender, come. Come here, buddy. Here he is. You having a good day? Yeah. All right. Let's see, where were we? Oh yeah, we had x times x minus 6 equals 16. Yeah, anyway, so from there, what we can do is multiply this out, and we're just solving a basic quadratic now. We've got x squared minus 6x equals 16. Move the 16 over. And then factor this thing. So this factors into, we're looking for things that multiply to negative 16 and add to negative 6. X minus 8. X plus 2. So then from there, we can set each of these individually equal to 0. So x minus 8 equals 0. X plus 2 equals 0. So here we get x equals 8 and x equals negative 2. Then with this one, just like with our radical functions and things like that, and our rational functions as well, we want to go back and check and make sure we get things that work with our original equation. So now that we've got both of our solutions, I'm going to check x equals negative 2, and we're going to check x equals 8 as well. So checking x equals negative 2, that would give us log base 2 of negative 2 minus 6 equals 5 minus log base 2 of 2 times negative 2. Okay. So the problem with this is we end up with logs of negative numbers, and we can't take logs of negative numbers. So that means -2 is an extraneous solution. So then we can check x equals 8, where we get log base 2 of 8 minus 6 equals 5 minus log base 2 of 2 times 8. So log base 2 of 2 and log base 2 of 16. Which is something that we can do. So it's not extraneous. So we could just stop there if we wanted to. But log base 2 of 2 is 1. And log base 2 of 16 is 4. So 5 minus 4 is 1. 1 equals 1. We're good to go. So x equals 8 is our only solution. Okay. So that one's a little bit longer. We had to go through, a whole bunch more things using our combining logarithms and then solving a quadratic after that, and then plugging the solutions back in to see if they actually work out. But that's probably the most complicated type of logarithmic equation that you guys will see. And you probably won't see that until maybe on your IXL section tomorrow. Any questions on any of the logarithmic equation stuff so far? Any numbers we're not sure where they came from? Any examples we want to go back to? Okay. And like I said, today's IXL is going to be fairly simple. We've only got one IXL section for our assignment for today. So today should be pretty short. Also, just so you know where we're kind of headed for the rest of the week. Since I made a couple changes, today is one IXL section. Thursday, since we don't have school tomorrow, is another IXL section. And then Friday, we're doing a Desmos activity with modeling with nonlinear regression. And that'll probably be something that we can complete together in class because, like we all know, that's the last day of the quarter. And so, we're not going to be meeting again the following Monday to turn things in or talk about anything else. I will see you guys again third quarter, most of you, hopefully. But yeah, so there's where we're headed to finish out the week. The assignment for today has just been posted. It is IXL F11. So the problems start out looking like this, where you just stick a 5 underneath both sides and figure out that R is equal to 5 to the second power, which is 25. Okay, so you guys are free to go and start working on this. I will post an exit ticket in a little bit. If you would like more examples, feel free to stick around and we can do more examples. Otherwise, have a wonderful day off tomorrow.